Welcome. How's everybody doing? So nice to see you back. Okay, so let me see what. Yeah, the password for the website is Kenyon with a capital K. All right, so let me share again. Okay. I wanted to let you know that, of course, most of you weren't here on the 3rd. I did have, oh wait, it didn't start sharing yet. I made a class video. It's about dictionaries. You don't have to watch it, but you do need to understand dictionaries, and that's of course what your quiz was today. And so if you still have questions, you might want to watch that class video. We didn't do any pojals, so that's me talking about dictionaries. Yes? Okay. Nothing's due today, although on the 10th, of course, tic-tac-toe is due. And important thing to remember about that, again, I've said this many times, but I'm going to say it again, is I give you a REPL to start with, and I give you unfinished functions, and I expect you to finish those functions, test those functions, and then use those functions to build the rest in the main line, to build the rest of the game. And then I expect the game to play exactly like what I give in here, okay? So I come to office hours today at 2:30 or tomorrow at 8 to 10. I still will have office hours tomorrow, although, as you know, classes are canceled for tomorrow. Yay. Okay. Today, we are going to talk about something very important, and it's a kind of a whole new way of thinking, although we've seen glimpses of it before, but we haven't really talked it through, and we're actually going to learn how to do it now. Now, so what we're going to learn about is how much of computer science is about reducing perceived complexity. Programs can be long and they can be hard, and if they're too long and they're too complicated for us to understand, we can't make them work. We can't build something that's more complicated than our brain can comprehend. So we can't make a program actually simpler, but we can make it simpler as we perceive it. And the way we make it simpler as we perceive it is by breaking it down into pieces that make sense to us, and then using those pieces to build bigger pieces. This is exactly the sort of thing you're supposed to be doing in tic-tac-toe, and the thing that you did do when you know, in the hangman game. So part of what this has to do, and the way we do this, is through something called abstraction and modeling. Abstraction is the concept of taking something and getting rid of the details that we don't need, right? I think of this past winter, I was out in Denver, and I went to the Claude Monet exhibition at the Denver Museum of Art, and it was amazing. They had most of his paintings there, and if you've ever seen his paintings, as he got older and older, he made things more and more abstract, right? And when you step back, you could see yourself in this forest, but when you're close, it's just brush strokes, right? And the idea is he was getting rid of the unnecessary details so that you can think about the feeling, I think, of being in this place rather than thinking about the details of the place. And so this is sort of the notion of abstraction. And so then we want to learn how we can use something called classes and objects to achieve abstraction and to reduce perceived complexity. So kind of to start getting us thinking about this, think about what you do to make a phone call, right? You pick up your phone, you unlock it, you open the phone icon, and you go to favorites and hit the picture or entry for the person you want to talk to, and then you're talking to them, right? And that's what you do to make a phone call. Now the question is what really goes on when you make a phone call? And the answer is a lot. Okay. In fact, in order to the amount of expertise and knowledge and technology and engineering that goes into make a single phone call is staggering. And there's no one person on the planet who understands all the pieces. In fact, there's no 100 people on the planet who understand all the pieces. There's so many layers, there's so many things going on, right? There's cell towers, and there's frequencies, and there's protocols, and there's negotiations, and there's digitizing of analog information and decoding of modulated signals, and there's encryption and decryption, and there's authentication, and it goes on and on and on. And the point is, if you had to understand how a cell phone worked to use a cell phone, nobody would use a cell phone, right? It would be too hard. If you had to literally manually do all the steps to make a phone call, for one thing, it would take you more than the rest of your life, and you wouldn't understand it anyway, right? And so, in fact, I would argue that the cell phone system on the planet is one of the most complex systems, and probably is the most complex system ever built by man. And to put it another way, just the complexity in one cell phone is probably, there's almost certainly more complexity in a single cell phone than there was in all the technology on the planet in the year 1900. It's mind-boggling. And so I hope I've made my point that a cell phone is actually, and the system that makes it work, is an extremely complicated thing. And it's so complicated that no person understands all of it, but if people understand pieces of it, they assemble those pieces together and make something that a 3-year-old can use, right? So the point is that the phone has an interface, and that phone, that's the interface on a phone is like a metaphor for communication. And we use those metaphors, we use those interfaces to activate a call. And when we're using our cell phone, we don't even think about the cell phone, right? We think about talking to somebody, right? We think about browsing the net. We think about making bids on eBay, right? We don't think about the technology. The technology is hidden. The function is what we see without having to understand it. The details are gone. So this is the very essence of abstraction, of the hiding of details. Again, cell phone system is one of the most complex things that we've ever built. So Oscar Dijkstra, famous early father of computer science, said, "The art of computer programming is the art of organizing complexity and of mastering multitude and avoiding its bastard chaos as effectively as possible." So finding a way to organize this so that we can understand it. He also said The competent programmer is fully aware of the strictly limited size of his own skull. Therefore, he approaches the programming task in full humility, and among other things, he avoids clever tricks like the plague. So the best software developers, the smartest people, realize they're not smart enough to do it the hard way. They have to figure out a way to do it that will work for them. And this revolves around the notion of hiding complexity. So we don't actually reduce the complexity. I mean, the cell phone system is a complex system. There's no getting around that. But we reduce the perceived complexity, and we manage complexity, and we hide complexity at different layers so that we can use these things without necessarily knowing how they work, right? And so, you know, for example, just real quickly, one more example, the computer programmer writes computer programs without really understanding exactly how the computer works, right? The computer manufacturers build the computers out of parts without necessarily understanding how those individual parts work, right? And so, and then even if you dig into those parts, like if you go into a processor, there's no one person who understands all the parts of a processor. Lots of engineers work together to build different parts of a processor that are then turned into a chip, and then they manufacture, you know, millions of these chips, and then they become things like, you know, processors and graphics chips and network interfaces and stuff like that. So how do we manage complexity? We manage complexity by building a model, an abstraction of what we want, and then hiding the details underneath the surface. Okay, so for example, a steering wheel is an abstraction, right? You don't know, I would say it's safe to say that none of you actually know what happens inside the hidden areas of a car when you turn the steering wheel. All as you know is that when you turn the steering wheel to the right, the car goes to the right, and when you turn it to the left, the car goes to the left. That's all you need to know, and unless you're a auto mechanic or a car designer, that's all you need to know, right? A credit card. Credit card's an amazingly complex thing, but what a credit card is for you is it's an abstraction of financial transactions. And you can pay people, and you can pay them with the belief that it's secure and people aren't going to be able to steal your money, right? And so it's an abstraction of secure financial transactions, right? Can you think of any other abstractions that you use?
I mean, when we are like programming on Python, we don't really know how the Python like process our codes, but we just type it in and assume it follows like a certain way of logic. And, yeah.
That's exactly right. You're right. So it turns out that Python is an abstraction of the computer itself, right? Because it turns out programming computers is really hard. It turns out that actually writing a program for the hardware is so hard that almost nobody knows how to do it. And I know how to do it. I know how to write programs for a computer at the lowest level, but I don't ever do it because it's too hard. Instead, Python provides an abstraction of the machine that makes the machine seem simpler so that I can write programs. That's exactly right. So another really simple abstraction is the light switch on your wall, right? You don't have to know anything about electricity. You don't have to know anything about wiring. You don't have to know anything about AC and DC and amperage and watts. You flip a switch up and the light comes on. You flip a switch down and the light turns off, right? That becomes an abstraction for whether you want the light on or not. So in programming, what we do is we create an abstraction of something and then we use it. Now you guys have already done this at some level, right? In the last project, you made a function called isWordGuessed, and you passed it a secret word, and you passed it a list of letters, and it returned a true or a false if the word had been guessed by those letters, right? And so that's an abstraction that solves a problem, and you could take that function and give it to somebody else and says, don't worry about how it works, this is what it does, and then they could use it in their program, right? So computer science is all about this. It's all about taking and breaking things up into these pieces and these abstractions and separating the how things work from what they do. And this has the impact or effect of reducing the perceived complexity. You don't have to think about things, right? Because in the, you know, once you wrote those functions for the Hangman program, the main line of Hangman was much simpler because you didn't have to have all these complicated pieces of code. You could say, oh, I need to know if they guessed it. I'll call the function. I need to know what letters are available. I'll call the function. I need to know, I need to get a valid entry from the user. I call a function. So hiding complexity in Python, how do we do this in Python? Well, as we've already talked about, one of the ways that we do it is by writing functions. But there's a fancier way of doing it, and we've actually already seen it some. It's called objects and classes. Now, can you think of anywhere in the class? We've already talked about this some. Where in the class have we seen objects?
We did turtle graphics.
That's right. We found out that a turtle was a class and that we could make a turtle, and that was called an object, and then we could call methods on it, right? So we could have more than one turtle, then each turtle we could draw with. We can make them go up or down. We can make them go right or left. We could change their color, right? And we didn't have to. Now, how many of you guys understand how turtle works, right? I don't know. I've never looked at the code to how it works. I just know what it does, right? Now, could you do graphics without turtle? Absolutely, but it would be a lot harder, right? And so turtle is a class, and anytime you have a class, it turns out you can make lots of things of that class. One way to think about it is a cookie cutter is kind of like a class, right? You have a cookie cutter and you have some dough laid out on the table, and you push the cookie cutter in, and you can make lots and lots of those things once you have the model for it. The class is like the model, and the object is like the thing that you're making, right? Cookie cutter is like the class. The cookies are like the objects. So in programming, a class is a model of something we want to represent. What might we want to represent? We might want to represent a tic-tac-toe board. We might want to represent an employee. We might want to represent a paycheck. We kind of already did that, but we didn't do it with classes. We might want to represent a character in a game, right? All of these things are things that we might want to build a representation for, and then we might want to do things with it. So one is like, what if we wanted to build a model, which we're going to see later, of a bank account, right? Turns out there's a real thing called a bank account, but we want to store information about the bank account. What do we need to know about each bank account? Let's see. I've got to fix this or it'll drive me nuts. What information is associated with a bank account, do you think?
There's an account number.
That's right. There's an account number,
There's a routing number.
routing number.
A name belongs to the account.
Yeah, the person who owns the account. What else?
The
The
actual
amount of
amount.
money inside of it.
Yeah, well, how much money is in the account? Maybe how much interest it is. Right? What's the interest rate?
Deductions.
What's that?
Like it like keeps track of like when you've got deposits and when you made
Mhm.
withdrawals.
Maybe you want to keep track of when money goes in and when money goes out, right? So these are things, this is what these are information about an account. We call this the state of an account. Like, in fact, you might even say to somebody, what's the state of your bank account? And they might say, it's pretty bad, it's pretty bad right now. I spent all my money on games, right? So the state of an account is the information about the account. And then the things that we do to the account are what we call methods on the account, right? What are some of the things that we can do to an account?
Withdraw money.
Withdraw money, yeah. What else?
Deposit money.
Deposit money. What else?
You can change them from a checkings to a savings.
So you can maybe transfer money between accounts. Is that what you're saying?
Yeah, transfer. Yeah,
Yeah. And you can check your balance, right? In fact, an ATM is kind of like an abstraction of your account, right? You can do all those things at an ATM. So when we think about a class, we think about those two things. We think about the interface. That's how we use it. And we think about the implementation. That's how it works. Okay, so a phone has an interface. That's how we use it. And inside it has all these components. And that's how it works. Interface is seen by the public. The implementation is only seen by the builders. So when we think of objects, there's sort of this idea of the object, that's the class, and then there's lots of versions of it, and they're all a little different because we put different information into them. That's like all the different iPhones, right? My iPhone, your iPhone, etc. So let's think about the bank account for a second. We've already talked about it a little bit. So a bank account, we have information, the things we know, the account name, the customer name, and the balance. And we have the actions we want to do on it. We create an account, we deposit money, we withdraw money, and we get the balance. We have a way of drawing this graphically. We kind of divide a class into three parts. Its name, the name of the class, the state of the class, which is a set of variables, and the methods or interface of the class, which is what we call the operations. And really, they're just functions, right? So a turtle is a class. That's the name of a class. The variables inside the class, well, we don't really know because we didn't write it, but we can kind of guess that maybe a class keeps track of what color it's currently drawing in, or a class keeps track of what direction it's currently pointing, right? And then we have methods. We know about the methods. We have, you know, a move, we have a turn, we have a pin up, we have a pin down, we have a change color, right? These are operations. So we can do this for an account class. For example, we can have an account class and it has a name of the account, a name of the customer, and a balance. And then we can have operations we want to do on the account. Now, the first one looks kind of funny. That's underscore, underscore, init, underscore, underscore. And what that is, something is called a constructor. Every time you have a class, you always have to have a way of making something of that class. Now with Turtle, we did that when we said, you know, Alex equals turtle parentheses. Actually, we said turtle dot turtle parentheses, right? So we're saying make a turtle and call it Alex. And so when we want to make an account, we have to give it a name and a balance. Actually, I wish I could change this but that's a picture. But because I should also have the customer name in there. We can withdraw an amount, we can deposit an amount, we can ask for the balance, we can ask for the name of the account. Those are operations. Now, again, an account is a class. It's a class of things. We can have instances of those things, or it wouldn't be very useful. We can have Bill Yakis has a checking account with this amount of money in it, and Amanda Blick has a savings account and this amount of money in it, right? And then we could maybe withdraw from there, and we could maybe deposit here. Maybe we could check the balance here. Maybe we could find out the name of this account, right? So those are things we can do with it. In fact, so this is a class, is this concept, and the objects are the things that are of that class. And we can have, and the class is like the design, and the objects are what we call the instances. So this is like the blueprint, and this is like the ones that we make. Cookie cutter cookies. So we can make lots and lots of accounts, right? So let's look at one. And, actually, I don't know why I did it this way. I'm going to fix something really quick. I had meant to do this before class. Sorry. But stupid. All right, so that looks a little better. Now we can show it. Okay, so here I have a main program, and here I have an account, and somehow this got skewed. I don't know how. Not sure what happened there. No, that looks a little better. Somehow it's going off the top. But anyway, I guess I'll. So here I have a program that wants to use accounts, and then here I have the implementation of it. And that's what we never saw with the turtles. We used them, but we didn't see how they were made. And so only looking at the left side for a minute, ignore this side, we see that from account, import account. So I'm importing this thing. And without looking at it, let's see the things we can do. Here I'm saying ACC1 is equal to account, parenthesis, checking, Bill Yakis 1,000. ACC2 is equal to account, savings, Sue Smith 2,000. Can you see, this is a lot like when I made a turtle, right? So if I take the name of the class and I pass whatever parameters it's expecting, I can make something of that type. Then I can use it. Here all I'm doing is I'm saying, hey, let's print out acc.getCustomer, acc1.getName, acc1.getBalance. These are methods that allow me to dig into that account. Then this one's got another typo error. This is supposed to be account 2 here. There we go. So we see that this refers to this. Now over here we have the actual class. Now as I mentioned before, underline, underline, init, underline, and underline is what automatically gets called whenever you create something of that type. So notice we have 4 parameters here: name, self, name, customer, balance. But here we only have 3: checking, bill, and the balance. Well, it turns out classes need to keep track of the variables for each object because each object has its own private variables. So self is a special extra parameter that you don't actually pass to it that keeps track of where my variables are at. So if I pass name, customer, and balance in, and I want to create one, what I'm saying is I want to create a new account, and I'm going to have to take the name that they pass in and put it into my name, take the customer that came in and put it into my customer name, and take the balance that they passed in and save it to my balance for this particular instance of the object. So when I call account 1, I'm making an account with these values. Now notice I also have a withdraw and a deposit and other things. Let's talk about that in a second, but first let's notice that balance actually has an equal 0.0. This is a way of saying this parameter is optional. If you don't pay for it, pay for it. If you don't use it, you automatically just get balance equal to 0. But if you pass it in, which we did, it's equal to the value that got passed in. Let's look at withdraw. Withdraw has a self, we always have self, and an amount, and it says if the amount is greater than self.balance, they're trying to overdraw, right? So we say print amount greater than available balance, and we don't do anything else. Else, we say self.balance is equal to self.balance minus amount, right? Minus equals amount. So we take that amount out, and then we return, this function also returns the balance. Then deposit does the opposite. It takes amount and adds it to the balance. Now, let's look at this. If we go here, open this up, and I'm gonna have to get out of here. I have this stuff all written. So notice, I'm going to fork it first because I don't want to mess up the copy that you have. Let's look at this. Let's run it first and see what happens. It prints checking Bill Yakis, saving Sue Smith, Christmas Cindy Jones, and then I say amount. Oh, did I mess something up here? I think I did. Yeah. I had changed this accidentally in the last class, and I didn't take it out, so I'm sorry. If you've gone here, go ahead and I need to go back to the original version. I apologize. I had modified this in the last class, and I forgot to clone it. I forgot to fork it first, and so this has got some stuff in there I didn't mean to have in there. See if it works now. Okay, so sorry, that was a little side trip. So notice, if we look at main, we create 3 accounts, and then I print the type, the name, and the balance of each account. Then I deposit 100 in account 1, which is Bill Yakis's. I withdraw 200 from account 2, which is Sue Smith's, and then I withdraw $2,000 from account 3, which is Cindy Jones. Now notice Cindy Jones, I didn't put an amount on. Then I do a print to create a blank line, and then I print them all again. So let's see what we have. We have Bill with 1,000 and his savings. We have savings for Sue Smith with 2,000, and we have Christmas for Cindy Jones, and it has nothing in it because we didn't give it a balance, and a balance was optional. Then I try to do a deposit, which it should be able to do. I try to withdraw 2,000 from Cindy Smith's, which should work because she has 2,000, and then I try to withdraw 2,000 from account 3, which is Cindy Jones, and I get an error. 2,000 is greater than the available balance, which is 0. Then I print it all out, and notice Bill Yakis has 1,000, Sue Smith has 1,800, Cindy Jones has 0. So notice we can use this without really knowing much about how it works. Like if I wanted to add another account, what could I do? Well, I could say ACC4 is equal to account, you know, Bill Gates. Oh, that's the name. And the account name could be Lot O Money. And, you know, let's say, oops, I forgot my comma here. So I have an account named Lotto Money, Bill Gates. And we'll put just a cool billion in there. That's a very small percentage of his money. But so we put a cool billion in there. And we could print out Bill Gates. Make a new account. Bill Gates is Bill. I could call this anything I want, by the way. I could call this Gates account, right? I mean, it's just the name. Gates. Gates. Oops. Gates. And could do it again down here. And we could go ahead and do Gates dot withdraw we'll do withdraw this much money here, and let's see what happens. So here we have Bill Gates with a lot of money, and of course I took $12 million out, which is not very much, but for him. See how that works? Now let's say we wanted to take some money out of Bill's account and put it into account 1, 2, and 3. Let's say Bill decides to give $10,000 to these 3 other accounts. Could we do that? Sorry. I'll let that stop now. What would I do to first of all, let's get rid of all this. Let's start from scratch. Let's say Bill Gates is going to just give $10,000 to each person. Well, in order to do that, let's take 30,000 out, right? So how do I do that? Well, turns out that I have a function called withdraw. Remember, we saw it, but we're going to look at how it works. I can say Gates dot withdraw sub 30,000. All right, and then I should be able to say account 1 dot dot deposit, right? I could do 10,000, and I could do that 3 times, right? 1 for each of the other accounts. Suddenly my computer decided it's dead. Okay, there we go. 2, 3, better put another C over here. So let's see what happens. So there we go. We gave $1,000 or $10,000 to each of those other people, and we took $30,000 out of Bill Gates' account, right? So can you see how we're managing accounts? Now we don't really know how. We haven't even looked yet really at how they're done. And so let's look at how they're done. Okay, here's the account. Here's class account. We always do parentheses object after it because account is a type of object. And then we have the init, self, type, customer, optional balance. Here we take the type and put it into this object's type, the customer name and put it in, the balance and put it in. And, oh, get rid of that. Didn't mean for that to be in there yet. And so now I feel like I need to fix this since I found another bogus thing. We shouldn't have this here. Okay, fixing the actual real one. All right, so notice we can get the balance, we can get the type, we can get the name, we can do it with, which we've seen all of those, we can do a withdraw and a deposit. Oh, look at this, here's a print function. Print, I don't pass in any parameters, I always have self, and I say print name, self customer. Oh, but it has the interest thing in there, so let's get rid of that right now. So I need to fix that on this one too. So, well, the point is that I have a print function, so let's try it out. We go over here, and instead of doing it this way, why not do this? Account1.print. That's a lot simpler than all this other malarkey, right? So I could do that for all three of these. Right, Gates, account 2, waiting 3, and 2. So we'll run it, and I had a thing on the end there, sorry. Well, apparently it's not account.name, it's type. So I got to fix this original one. You can pull the original one if you want. Let's make sure this works. Yeah. Sorry. So here I'm calling the print function. The print function prints the name, customer, and balance, and we see it here. Actually, it would be nice if I did this. Make it look a little nicer. But so I've got this class, and I can use this class. Now, let's say we're not happy with this account class, and we want to modify it so that we also keep track of the interest rate. What would we do? Well, why don't we do this? Why don't we go into the init, the constructor, we call this, and let's add interest, and let's make that be a default of 0.0. And let's take that number, and if they supply it, let's take that and put that into a thing called interest. Now let's see if it still runs. It still runs because this is an optional thing. But now what we could do is we could come in here and we could say this has 3.0% interest. This has 4.0. This has 5.0. And maybe this has 6.0, right? Oh, but that's not going to work because we have to give a balance. It turns out that if you want to give this one, you also have to give this one. You can't just skip one. So let's start Cindy out at 0. So now we've added interest. Let's see if it still runs. It does, but of course interest doesn't print out. But since I have a print function now, which by the way, let's go ahead and replace all this with the print function because it's so much cleaner. We go down here, we look at the print function, and let's go ahead and add interest. Well, I could probably say rate. And then I'm going to do self, right? Because that's where my interest is. So I'm going to go ahead and add interest. Now I run this, and sure enough, it prints for each customer their name and interest rate, right? So you can see how I can modify this without modifying this, and I can modify this without modifying this. There's this independence. And so I didn't change much here. I just added some interest. I'm still taking 30,000 from Bill Gates and giving it to the other 3 people. And my class, again, has the constructor. This is the thing that builds, and it expects either 2, 3, or 4 entries. In fact, I could do this. I could have Cindy Jones have no balance and 0 interest rate. Let's see if that works. Sure enough, it does. Cindy Jones has 0 interest and 0 balance. Now let's say I wanted to add a function to this called accrue interest. In other words, what I'd like it to do is when I call it, it adds 1 month's worth of interest to the class, to that particular object. If I'm going to do that, that's going to be another method. Okay, so I can say accrue interest. Now we always, when we write a function, we always start out with self, always, if it's a method within an object. And then accrue interest doesn't need anything else because it just adds interest to the account. So what do we need to do when we, oh, I forgot my def. What do we need to do? Well, how do we accrue interest? Well, it turns out that 4.0 interest is really 0.04 interest. So what we should do, and of course this is for a month, and so the actual, I'll say interest rate is going to be equal to self.interest divided by 100 to get a fraction, but then we need to take all that and divide it by 12 because we only want 1 month's interest. Then what I should be able to do is take self.balance, right? And how do we compute interest? Well, it's just going to be equal to self.balance plus itself. Sorry, self.balance is equal to what it was plus self.balance times the interest rate, right? What that's going to do is it's going to take whatever the balance is plus the little bit more when we multiply this small fraction. And that's it, we're done. Accrue interest doesn't need to return anything. So let's try this. Oops, I'm in the wrong one. Did I do this in the wrong thing? Yes, I did it in the wrong one. Sorry. We'll take this one out of here. Sorry, I did it in the wrong thing. So I added this accrue interest. So now I have a new function on something. So what if I do the deposits and I'm going to print again, but what if I go ahead and say for each one, I forget what did I call that function again? Accrue interest. So I'm going to call accrue interest on account 1, call accrue interest. So this should add 1 month's interest. So if we run this, we get more stuff. Now, we're getting so much stuff, it's becoming hard to separate it all out. So let's put a print in between each one of these. So here's the 4 accounts originally, then we added the money from Bill Yakus, and now notice this account went up by $27, this one went up by $40, and this one went up by a whole bunch because it's a lot of money and it's a high interest rate, right? So I called accrue interest on each account. Now, what if I wanted to see, what if I wanted to add a year's interest to everybody's account, but I only had the accrue interest for a month? What could I do?
You'd have to multiply it by 12, but I'm not sure where you multiply it by 12.
Well, what we could do that, but how about this? What if we just do this? For I in range 12, why don't we just call accrue interest 12 times for each customer, right? That's going to take them through a whole year of interest. And that's actually that's very easy because we don't have to figure out how to compound the interest. If we assume that the interest is just compounded monthly, we do this, and notice it goes up by a lot more, right? In fact, that once we've done this, we can say, oh, how much for 5 years? That's 60 months. There, look, 11,000 went up to 12,777. That's for 5 years. Here's for 10 years, right? Bill Gates is getting richer fast. Money's almost doubled. So isn't that cool? So we have accounts, and it's really easy to mess with these accounts. And over here, we have the account itself. Now, let me do something kind of funny over here. Once I've done this, I can do all sorts of cool things. What if instead I wanted to make a list of accounts? I can have lists of objects. And so watch this. What if I had another file over here, and I'm going to call it accounts.csv. And in that file, I'm going to make, you know, Bill Yakus, comma, oh wait, that's savings, comma, Bill Yakus, comma, $1,000, comma, 3.3% interest. And then I'm going to have a checking, Sally Smith, comma, 23,4456. Oops, I don't want a comma there. 0.00. We'll probably do that just to keep things nice. And she has an interest rate of 4.2. And then I could have, you know, lot O money account, and this is Bill Gates. And I could have $1 billion in there and a 5.8 interest rate, right? So I've made a file. Could I load those into accounts? So I got nothing here. Well, let's see. I can certainly open a file, so I could say account file, AF I'll just call it, is equal to open accounts.csv. And let's just prove to ourselves that we can read through this. Print. Well, let's do this. Let's take and say for line in account file, and then let's do a data is equal to split Okay, and then let's print data just to see if this thing works. It's data is equal to line dot split, right? So I want to split the line based on the comma and print the data. And there we go. I read it in. Oh, but look, I have that /n at the end. So let's do dot strip dot. And there we go. That looks nice. Oh, but we're going to have to be careful because the numbers are strings. So let's see if we can make a list of accounts. So I'm going to say accounts and make it be in an empty list. And here, what I'm going to do is I'm going to make an account. So let's make an A account is equal to accounts. Remember, it's got a capital, right? I'm using my class. Account sub, let's see, it expects the name of the account first, the type of the account. So that's going to be data sub 0, right? And then the name data sub 1. Now the next two are floats. So I better do that. I better say float sub data sub 2 and float data sub 3. Okay. So if this works, let's see if it works. Oh, it crashed. What did I do wrong? Oh, I didn't put my parenthesis in the right place. There we go. Let's run it now. Seems to run, but of course we want to see the accounts. So what I should have done, what I want to do is take those accounts. Like what I could do is I could do a dot print just to see if this works. And let's see if it prints the accounts. Sure enough, it prints the accounts because each of those is accounts. But instead of printing them, let's do this. Let's do accounts dot append A. Now I should have a list of accounts. So for example, I should be able to do a sub 2 dot print. Let's see if that works. Oh, it's not a sub, it's accounts. Because that's what I called my list. Okay. Sure enough, the third, and I can add stuff in here now, right? So I could do another one. I could do house, you know, Sam Jones. And I run it. Of course, that doesn't change anything because I didn't, I'm only printing this out. Now what I could do is I could say for A in accounts, because this is a list of accounts. I should be able to say a dot print and print each account. Let's see if that works. There you go. So here I have a file, and here I have my account class, and here what I'm doing is I'm using my account class. I'm reading data in and creating accounts and maintaining a list of accounts. In fact, what I could do is I could do this. I could, let's say I want to add a month's interest to all the accounts. Well, I could do for A in accounts, and I could do a dot accrue interest. Is that what I called it? Yeah. And now when I print it out, they have more money, right? And so that's pretty cool. I'm reading files and I'm using accounts. What if I wanted to, is there any other features I might want to add to an account? Let's look back at the account class. What other things might we want to do to an account? Seems like we've got most everything, doesn't it? What if occasionally the interest rate changed? Could we do that? Could we write a function for it, a method for it? Let's think. Def update interest. And what would we want to pass to update interest?
Can you say that again?
Well, one thing for sure, we know we always have self at the first. Anytime we write a method, it starts with self. And then if we're going to change the interest, we want to pass in a new interest rate, right? And then we can just change it. We can say self dot interest is equal to new int. No, I used a capital I here, right? So down in here, over in mainline, let's say before we do the interest rate here, let's do a for A in accounts. What if I wanted to add 10% to everybody's interest rates? Things are going good, everybody's interest rate goes up by 10%. Clearly, I could just set everybody's interest rate to something. For example, I could do a.set. What did I call it? I don't remember. Update interest. Update interest. I could set it all to, 5%. Let's see if that works. We run this, and sure enough, everybody has an interest rate of 5%. Now, it turns out that in Python, this isn't true in all languages, but in Python, I can access all the self variables just by giving the name of the class. So I could say, well, before I do that, I could do, if I do this, print account sub 0, which of course is going to be Bill Yakis, dot name, dot type. Notice savings, right? It turns out I can access the variables directly. If I want to look at interest, I can actually look at interest. Run this. There's Bill Yakis's interest rate is 3.3%. So if I wanted to, what I could do is I could go through my list of accounts, and if I want to give everybody a 10% interest boost, I could do this. Let's think about this. A.set or update interest. And what I want to update it to is A dot the current interest. Right, that's going to actually look up the current interest, and I'm going to say times 1.1, because 1.1 is going to be 10% more, right, if you remember your math. So let's see if when I print the accounts out, if their interest rates go up. Yeah, look, everybody's interest rate went up a bit. This one ended up going up to this, had this really long number, but, right? So, isn't that a lot easier way to deal with accounts is to hide the details of the accounts in the object? That's a lot of code there, but when I use it, it's easy. Okay? So on next Tuesday, what we're going to do is we're going to you're going to do a POJL on this, and we're going to learn some more. You're going to learn some more about classes. So we're going to look at classes again on Thursday. I mean, next Tuesday. Well, this calendar seems odd. Wait, no. Right. So, right. Well, yeah, right. Next. Yeah. I showed the POJLs this time, but we're actually going to do the POJLs the next time we meet. And we're going to actually be doing classes all of next week. So we're going to spend some time on classes. And just to give you a heads up, I'm going to show you what our last Python program is, because then we're going to shift to a new language, C++. Our last project uses classes. And what you're going to do is, we've been writing games, so we're not going to quit. We're going to write a blackjack game. Now, how many of you guys have played blackjack? Right? It's a simple card game where you try to get as close to 21 without going over. And I'm not going to go into the details, but there's actually a web version. I don't know if this works, actually. I think this isn't going to work. I'm going to have to fix that. But there's lots of online blackjacks you can play, or you can get a blackjack program for your phone or whatever. But what I do is I give you I'm actually doing it all in one file. Maybe I'll update that though, come to think of it. But actually, I give you a card class because cards are in a game. I give you a deck class because a deck is in a game. I give you a hand class. And then you write a program that plays, but the details of hands and cards and decks are hidden inside classes. So that's kind of where we're heading. All right. So that's all I really wanted to do. We're done a little bit early today, but I'm not going to keep you longer. If you have any questions, you can ask me now, or you can come to my office hours at 2:30. Okay, well, I'll see you guys later. If I don't see you before, have a good weekend.
Thank you, Professor.
Thank you.
Thank you.
As well.
Thank you, Professor.
Professor,
Yeah.
I needed to take the quiz. I couldn't come to my section. I emailed you. Professor Harrington had an exam that interlooped 20
Oh, you
minutes
can
into
take it
your
now.
class.
You can just go take it right now.
Okay, have you opened it? Okay,
Yeah.
thank you. What's the password?
look up L-U-L-O-O-K, capital L-O-O-K, capital U-P.
Okay. LOOKUP.